So I'm going to talk to you today about Funhouse. The problem that Funhouse solves is that of data leaks, and more specifically, data leaks that are enabled by the high degree of access that internal employees have to data. Now, at an extremely broad level, the way you solve this is by limiting employees' access to that data. Beyond that, Funhouse has two main goals. The first is that we want to redact data rather than simply blocking queries. And on one hand, this has the benefit that applications don't have to deal with denied queries and error-checking query results. On the other hand, this allows us to reason on a more nuanced level about degrees of access. For example, some employees might have access to the last 4 digits of a credit card, whereas others might have access to none at all. The second main goal is to allow companies to operate under the principle of least authority. Now, the reason that this is challenging is because the access that an employee needs is changing constantly. So in order to follow that access need, we're going to need to be able to support constantly changing permissions. So in a simplified model of the world, where we have just an application and a database, the question becomes, where do we redact? One approach might be to rewrite the query before it runs on the database. Some systems take this approach, and the benefit of this is that we're able to look at the query and understand what it's going to fetch, but it requires us to understand SQL and also to reason about how we can insert into the query the logic for generating the redactions that we want. On the other hand, you have result rewriting systems that look at the data that the query produces and edit it before returning it back to the application. The benefit of this is that we can look at the actual data and implement redactions on top of it. However, it requires us to understand after the fact what happened in the database so that we can understand which data is sensitive and what we need to redact. A little bit dissatisfied with both of these approaches, we came to the insight that what makes both of them challenging is that it requires us to reason about what happened inside the database, either before or after the fact. So the approach that Funhouse explores is one of integrating redaction into the database itself. So we now have an updated picture of the world where, rather than just having a normal database, we have a Funhouse database. Now, of course, a Funhouse database has to store the data just like any other database would. And to set up this database, database administrators insert into the database redactions. And Funhouse stores these redactions, which consist of a predicate that specifies what data the redaction should apply to, as well as an operation that might include things like modify or decorrelate or remove. In doing so, database administrators have defined a baseline level of access that employees should have. Now, in order to deviate from this baseline level, developers insert into workflows upgrades. Upgrades generate access, give the requesting employee access to the data that is required for the workflow that they are currently in. Funhouse also stores these upgrades, which consist of simply a predicate and also a timeout value. Upgrades nullify redactions for any of the data that they select. Now, one way of doing this would be to just include upgrades whenever needed, but this would also allow employees to upgrade whenever they like. And so, however, we also said that upgrades are a common application operation. So we need to find a trade-off between explicit authorization in order to prevent data leaks, but also implicit authorization in order to avoid overprompting. On the explicit authorization, on one hand, we can now allow other employees to grant authorization for upgrades. The way that we understand whether they're allowed to do this is that we use a SAT solver, and the question that we are trying to answer is, would the upgrade ever overlap with any data that would be redacted for the authorizing employee, logically sort of enforcing that employees can only authorize access to data that would be unredacted for them themselves. Additionally, end customers can authorize access to data that is associated with their identity. The implicit authorization workflow remains a little bit of a question, but we're thinking along the lines of templating upgrades, which takes ideas from Blockade and basically allows us to understand what upgrades that are part of routine workflows look like and automatically authorize those. In addition to these two authorization workflows, we log all of our upgrades, and you could imagine building some sort of anomaly detection or throttling on top of this log. So now that we have redactions and upgrades, the application runs queries just as it would on any other database. So the first thing that Funhouse has to do after loading the input data is redact it, taking into account the upgrades that the employee currently has, and we can then return the redacted results. This has the main benefit that we've now solved the challenge of how do we support constantly changing permissions. However, we've also put ourselves in the position of having to recompute the redaction on top of the data for every query, which has now put us in the game of query optimization, a game we know how to play very well. So one of the standard query optimization techniques is to reorder operators within the query plan. However, this has slightly nuanced interactions with redaction that require us to make sure that there's no read-write overlap between the two operators that are being swapped. So let's look at an example. Suppose we have a redaction that changes the email of some customers, and now inside the query, we're filtering based on ID. We can, and in fact should, swap these operators, which allows us to redact only one row as opposed to the entire data. However, if we are filtering based on the email, swapping these two would leak the actual row even if the email is redacted, and so we don't swap these. We implemented Funhouse in about 5.3 thousand lines of C++. This includes a query planner and executor, as well as an interface for integrating redactions and upgrades. In order to evaluate it, we built a small synthetic hotel database that included three queries, as well as redactions and upgrades. You can see the results displayed here. The x-axis shows the queries, and on the y-axis we have the query latency. We first just ran a baseline to understand what our query executor looks like. We then added redactions, but did not reason about redactions in our optimizations. Next, in orange, we added the optimizations to reason about redactions, and finally, we added upgrades. The main takeaway here is that even with relatively coarse-grained and broad optimization techniques, we were able to reclaim much of the overhead that was added by redactions. So finally, to summarize, I've presented to you today Funhouse, which has the goal of limiting employees' access to sensitive data, and does this by integrating redaction into the database itself. Thank you very much.
Shubham Mishra, UC Berkeley, nice talk. So I was wondering if this system has any extra overhead for the database administrators or programmers that are working with these applications over, like, just using views and normal SQL permissions.
So your question is, does it have overheads over what?
Like overheads for the database administrators, like to specify reduction, and over using just views, like SQL views and SQL permissions.
Yeah, that's great. So the overheads are about the same. The content of what they do is a little different. So when you are defining views or ACLs or anything like this, at the beginning you create basically a set of options, and then sort of as employees progress through different stages of workflows, etc., you figure out which one sort of currently applies. Whereas in Funhouse, and sort of that's one of the things that we think is really cool, is that it's a little more intuitive, because at the beginning you're creating a baseline level of, okay, well, sort of ground zero, what are they allowed to freely access and query and know about no matter what? And then within the workflows that require access, the developers insert sort of upgrade statements that give the employee access to the data needed for that workflow. So the database administrators really only create sort of the baseline, and then the developers inside the workflow have an understanding of what access is needed and then integrate that.
Thank you.
Thank you.
And Bunion with EPFL, this is great work. The way you're describing upgrades, you're describing them, if I understood correctly, as sort of something that happens dynamically within the workflow as a function of the workflow. There's another more static way to look at things, which is to sort of have a role-based access control approach where users have different roles. The redactions are different depending on the roles. The redactions are in the database, and then each query is effectively authenticated by a user acting in a particular role, and that role may change, but these roles are sort of predefined within the system, as opposed to sort of something that is an upgrade being dynamically generated on the fly. And I guess between those two, there's a trade-off between the flexibility and expressiveness, but also the complexity of implementation. I was wondering if you thought about it.
Yeah, I think that's a great point. So I think one of the reasons that we wanted dynamic upgrades, two main reasons actually. So the first is that as workflows change, and sort of you add one or you edit one or whatever, you don't have to go back to the actual setup. And additionally, if you have something where it's just role-based, that's basically like saying, oh, you can, that's an implicitly automatically authorizing access to each of those upgrades that is needed. And we wanted to make that a little bit more explicit, a little bit more logged. And additionally, this allows you to do sort of out-of-band communication, where some workflows, sometimes you just need to directly interact with the database because it's you're doing something out of the ordinary that's not part of the normal workflow. And so this allows you to do that.
All right. Thank you.
Thank you.
Let's thank all the speakers.